In this video, I want to do a quick overview of the solubility table that is in the lab manual. And by the way, the solubility table in the lab manual is better than the one in the textbook. Now, solubility tables are generally can be frustrating. So let me go over some key features to this particular solubility table. One thing to keep in mind is that there is a group of ions here that are always going to be soluble in solution, no matter what they're paired up with. So one way to think about this solubility table is it's almost like it's creating a sentence in a way that these ions over here are going to be soluble unless they're paired up with ions on this side. So for this first line, what it's saying is that, and I'll mention the specific ones that are most common, sodium, potassium, nitrate, and the others, they're always soluble. There's no exceptions. There's no salts where you're going to see them being insoluble. That's why you see sodium and nitrate salts as very common reactants in precipitation reactions and other reactions as far as that goes. Now for these other ones, and I will just use chloride as an example. What this line is saying is that, okay, so these halogens here, typically they are going to be soluble when they're paired up with some kind of cation. But there are 3 exceptions that are going to be insoluble. So just to run through the full list here for chloride, because it's a fairly short list, that means that silver chloride will be a solid, lead chloride will be a solid, and then this mercury salt will be the solid. Again, any other formula with any other ionic formula with chloride pairing up with a cation is going to be soluble. And this could go on all day long in terms of the number of chloride salts that are possible. And the same thing can be said for bromide, same thing can be said for iodide. Sulfate is read the same way. Most salts of sulfate are going to be soluble, except there are 4 salts that are insoluble. So just not to write all of them out, these are the ones that are considered soluble, and then, well, maybe I will write the rest of them out. It's easy enough. So those are the only 4 salts of sulfate that's going to be insoluble. A little heads up, calcium sulfate is kind of on the borderline. It's actually slightly insoluble. So depending on the conditions for a particular like concentration of reactants, you may not get a solid. But that doesn't matter. For us, it's going to be a solid. And then in this final group, basically what these 4 anions are saying is that they most likely are going to be insoluble when paired up with a cation from the periodic table, except for these 4 cations that are always soluble. So like sodium hydroxide is always soluble, but something like iron hydroxide is going to be insoluble. So the vast majority of salts from this cluster here are going to be insoluble in solution. This is one of the reasons why this chart is better than the one in the textbook. The one in the textbook I think is missing carbonate and I think sulfide as well, which is puzzling to me. Anyway, there's a quick overview of the solubility table from the lab manual. I hope this helps. Thanks.